A stack is a fundamental data structure that follows last in first out principle, that is LIFO. It is named stack because it resembles a stack of items like a stack of plates or books. In a stack, the last element added is the first one to be removed. The standard operations that can be performed on stack data structure are as follows. Push. This operation adds an element to the top of the stack. Pop. This operation removes the top element from the stack. Peek or top. This operation allows you to view the top element of the stack without removing it. Is empty. This operation checks whether the stack is empty or not. Size. This operation returns the number of the elements currently present in the stack. Now let us see the working of stack. First we will see the push operation. Before adding an element to a stack, it is verified whether the stack is empty. If we try to insert an element in a stack and stack is full, then the overflow condition occurs. When we initialize a stack, we set the value of the top as -1 to check the stack is empty. When the new element is pushed in a stack, the first value of the top gets incremented. That is, top is equal to top plus 1. So the top -1 becomes the top is equal to 0, and the element will be placed at the new position of the top. First, we will add element 10 to the stack and the top will be incremented from -1 to 0. The elements will be inserted until we reach the maximum size of the stack. Next, we will insert 20 and the top becomes 1. Push the element 30, the top is now 2. Push the element 40, the top is 3. And push the element 50, top is 4. And the stack is full now. We cannot push the elements further in the stack. If we do so, overflow condition occurs. Now let us see the next operation, that is pop. Deleting the elements from the stack is called pop operation. Before deleting the element from the stack, we check whether the stack is empty. If we try to delete the element from the empty stack, then the underflow condition occurs. If the stack is not empty, we first access the element which is pointed by the top. Once the top operation is performed, the top is decremented by 1, that is, top is equal to top minus 1. Here we have a stack that is not empty. So first we will remove the element 50, next we will remove the element 40. Now remove the element 30 and remove the element 20 and remove 10. Now the stack is empty. Next we will discuss the applications of stacks. Stacks have numerous applications across various domains in computer science and beyond. Here are some common applications of stacks. The first one is function call stack. In programming languages like C, C++, Java, and Python, a stack is used to manage function calls. When a function is called, its parameters and local variables are pushed onto the stack. When the function returns, these values are popped off the stack. The next application is expression evaluation. Stacks are used to evaluate arithmetic expressions such as infix, postfix, and prefix expressions. Infix expressions can be converted to postfix or prefix notations using stacks for easier evaluation. The next application is backtracking algorithms. Stacks often used in backtracking algorithms such as depth first search. During the search process, the states and choices are pushed onto the stack, and when a dead end is reached, the algorithm backtracks by popping from the stack. The next application is undo mechanisms. Stacks can be used to implement undo mechanisms in the text editors and other software applications. Each action performed by the user is pushed onto the stack, allowing for easy reversal of the actions by popping from the stack. Next application is browser history. Web browsers are used stacks to implement the back and forward navigation buttons. Each visited page is pushed onto the stack, allowing users to navigate backward and forward through browsing history. Next application is parenthesis matching. Stacks are used to validate the correctness of the expressions containing the parentheses, braces, and brackets by pushing the opening symbols onto the stack and popping them when closing symbols are encountered. The balance of the symbols can be checked. The next application is compiler and interpreter implementations. Stacks play a crucial role in implementation of compilers and interpreters for programming languages. They are used for parsing code generation and managing the execution environment. The next application is memory management. Stacks are used in memory management systems to allocate and deallocate memory for function calls. And local variables. The stack memory is automatically managed by the system, making it efficient for managing memory in a structured manner. These are just few examples of many applications of stacks in a computer science and software development. Stacks provide a simple and efficient way to manage data and perform various operations in a wide range of applications.
Like, comment, and subscribe.